Okay, welcome back. This is the part 3 video of electric bike battery pack rebuild. And I haven't had time to get back to this third video until now, so let's get started here. I compared the new pack to the other bike pack, and what I found was that the other bike pack, factory pack, would start at 54 volts and drop down to 52 volts under full acceleration with 20 amps of current. The voltage and current shown on the display on the bike. Whereas this new pack would start at 52 volts and drop down to 45 volts as it approached 20 amps. So this was a significant difference, and I had to find out what was causing it. What I eventually found was there were no bad cells. All cells were charged to 4.01 volts. I was also concerned that maybe the battery charger wasn't charging one of the cells, but in fact all cells were being charged properly. And what I found was the resistance of these cells was different than the pack of 4 cells. That makes sense. The resistance each one of these 9.9 amp cells measured 52 milliohms. Whereas the 4-cell pack, I had one good pack left out of the whole battery, measured 20 milliohms. So it's 2.5 times more resistance, which is causing a significant voltage drop. This battery internal resistance is one factor I didn't consider when I made the switch in cell sizes. So the internal resistance of the battery drops voltage, which leaves less voltage for the bike itself, and that's why the severe voltage drop when you go to full power. Since the old battery cells are in parallel, that means that each one of the old battery cells was 80 milliohms. Divide that by 4, you get 20 milliohms. So 2 of these other batteries are going to be 25 milliohms, and I think we'll be fine with that. So instead of using one cell, I'm going to have to use 2 cells for each 4-volt increment of the battery pack. So I just want to drop off this video, let you know what happened and why I never finalized it. I didn't finalize it because I didn't know why the battery voltage was falling so much. I initially figured it was a result of the thinner straps I could get to weld the batteries together. I couldn't get the thickest straps I wanted, so I had to use a slightly thinner one, and that does probably cause a little bit of voltage drop, but most of the voltage drop is due to this internal resistance of the batteries. But now it makes sense. With 2.5 times the internal resistance, and of course you're going to have a significant voltage drop. So the next video that you find here will be the results of adding a second battery. So now I got I got 25 milliohms of resistance per battery. And that will help it a lot. I don't know if it'll be enough or not. Time will tell. For those that are interested, my test vehicle was a 1 ohm 5 watt power resistor. I simply put a voltmeter, digital voltmeter across the power resistor, and I connected it across the battery. And when I measured the voltage across the resistor, voltage equals I times R, therefore the current is voltage divided by R, which came out to be 3.8 ohms. And then the resistance of the battery is the open voltage of the battery minus the active voltage of the battery, which in this case was 0.2. So 3.8 into 0.2 ended up 52 ohms for meant to say 52 milliohms for the 9,999 milliamp hour battery.